Welcome to Educator.com. In the previous lesson, we talked about dividing rational expressions. In this lesson, we'll discuss dividing polynomials. So we're going to begin by talking about dividing a polynomial by a monomial. And in order to accomplish that, to divide a polynomial by a monomial, you need to divide each of the terms in the polynomial by the monomial. And if you think about this in terms of numbers first, it makes the concept of working with polynomials easier. Okay, so for example, if you were to divide 8 plus 10 plus 12 by 2, you could say, okay, 8 and 10 is 18 plus 12 is 30, divided by 2 is 15. Another way to accomplish this would be to say 8 divided by 2 plus 10 divided by 2 plus 12 divided by 2 gives 4 plus 5 plus 6. Again, 15. So this second method is the way we're going to approach dividing a polynomial by a monomial. For example, if you were asked to divide 8x cubed plus 4x squared plus 6x by 2x, okay, so this is a polynomial being divided by a monomial, which ends up giving you a rational expression. Recall in the other lesson, we were talking about dividing one rational expression, one fraction, by another rational expression, another fraction. Now we're talking about dividing a polynomial by a monomial. So this is equivalent to 8x cubed divided by 2x plus 4x squared divided by 2x plus 6x divided by 2x. Then we just use our usual rules for dividing monomials. So 8 divided by 2 gives us 4. X cubed divided by x, subtract 3 minus 1, so just subtract the exponents to get x squared, plus 4 divided by 2 is 2, x squared divided by x is x, plus 6 divided by 2 is 3, the x's cancel out. So this is our solution. So the approach to dividing a polynomial by a monomial is to divide each term in the polynomial by the monomial. A little bit more complicated is dividing a polynomial by a binomial. First step is to try to factor the polynomial. Sometimes that's not possible, but if it is, this is an easy method for division. If you do this factoring and you find that one of the factors is equal to the divisor, then cancel that common factor. The quotient is the remaining factor in the dividend. So writing this out and just reviewing some terminology to make this clearer. Okay, so here on the top we have the dividend. In the bottom, the number we're dividing the dividend by is the divisor. And if you were to write division this way, here you would have the divisor, and here the dividend. And we're going to be using these terms throughout today's lesson, so just make sure you have that straight. Okay, so first try to factor the polynomial. So let's try to factor the polynomial. And I have x plus something times another binomial, x plus something else. Well, factors of 6 would be 2 and 3, and 1 and 6. So I'm going to try 2 and 3. So that gives me x squared. The outer terms give me 3x, plus the inner terms, that's 2x, which is 5x. So correct middle term, and then the last term is 6. So that's correct factorization. All of that divided by x plus 2. So if one of the factors is equal to the divisor, cancel the common factor. So I do have a common factor here. One of the factors is equal to the divisor. canceling my common factor. Therefore, the quotient, the result of this, is the remaining factor in the dividend. So as you can see, everything worked out really cleanly and nicely for this one, but that is actually not always the case. There are situations where you can't factor the polynomial, it doesn't work out, you don't get cancellation. So in that case, you need to do long division. So you're of course familiar with long division using numbers, and you may be so familiar with it that you don't even think out what is each step I'm performing. Well, when you're working with polynomials like this, you need to really be aware and know what the next step is. So I'm going to begin by reviewing the steps of long division, just using numbers. So let's go ahead and take 259 divided by 3. Okay, first step is I divide 3, doesn't go into 2, so I go to 3 into 25, and that goes in 8 times. Then I multiply. 8 times 3. So after dividing, you multiply 8 times 3, and that equals 24. Next step, subtract. So I'm going to subtract 24 from the dividend here to get 1. After that, I'm going to bring down the next digit. Okay. The next digit was 9. That gave me 19. Again, I divide, and I find that 3 goes into 19 6 times. Multiply again to get 6 times 3 equals 18, and then subtract. This gives me the remainder of 1. So the solution here is 86 with the remainder of 1. This same approach can be used with dividing a polynomial by a monomial. So consider this problem. I have 4x squared plus 6x plus 2. And I want to divide that by x plus 2. Okay, the way to approach this is to take this first term here, this x, and divide it into the first term here. And x, so it's 4x squared divided by x. So I can go over here and do my division. You can do it mentally or write it out. And I see that I can cancel 1x, so that's going to give me 4x. Therefore, 4x squared divided by x is 4x. So I'm going to line that up here over this x. So I divide it. Now I'm going to multiply 4x times x plus 2. Just the way I multiplied over here, 8 times 3. So that's going to give me 4x squared plus 8x. So multiplying 4x times x is 4x squared. 4x times 2 gives me 8x. And I'm going to go ahead and subtract this, 4x squared plus 8x. 4x squared minus 4x squared gives me 0. Subtracting, so if I have 6x and I'm saying minus, then it's minus 8x. We can also look at this as changing this to addition and then changing the sign for each of these to make sure that we don't make an error in the sign. So it's really 6x minus 8x to yield negative 2x. Next, bring down the next digit. So that's going to give me plus 2. Bring down next digit. Okay, multiply, divide again. So thinking about 2x, negative 2x divided by x, the x's cancel. That's going to give me negative 2. So x goes into negative 2x, negative 2 times. So I'm going to write a negative 2 up here. Then multiply. And what I'm going to be multiplying is negative 2 times x plus 2 to get negative 2x minus 4. Okay, Once I've multiplied, I subtract what I ended up with. So negative 2 times x is negative 2x. Negative 2 times 2 is negative 4. But I am subtracting. That means what I'm really doing is adding. But I'm going to change the signs to the opposite. So subtraction is just adding with the opposite. Negative 2x and 2x cancel. And then I get 4 plus 2 equals 6. So I get a remainder of 6. So my answer here is 4x minus 2 with the remainder of 6. Now, there's a way to check this, and it's worth checking because long division with polynomials is complicated enough that errors can be made. So the way you check it is to realize that the dividend equals the divisor times the quotient plus the remainder. So I'm going to go back and I'm going to say, okay, the dividend, if I did this correctly, the dividend is going to equal the divisor, which is x plus 2, times the quotient. This is my quotient right up here. The result of the division is the quotient. So that's 4x minus 2 plus the remainder, which is 6. So plus the remainder. Okay, so let's see if this works out. So multiplying my first terms, that gives me 4x squared. The outer terms, negative 2x. Inner terms, 8x. Last term, so just using FOIL, gives me negative 4 plus 6. Doing some simplification, I get 4x squared. Negative 2x plus 8x is 6x plus 2. I check this, and this does check out. So I know that I did my long division correctly because my dividend equals divisor times quotient plus remainder. So this checks out. Again, what you're doing is just each step of long division, just as you do with numbers. Okay, sometimes we have missing terms in the dividend. You can actually have missing terms in the divisor as well, and those need to be handled the same way. But in this course, we're just introducing these concepts, and we're just going to stick with talking about a dividend that may have missing terms. Okay, so missing terms. What does that mean? They are terms with a coefficient of 0. If you have those, you need to add the missing terms to the dividend and then perform the long division. What we mean by missing terms is, let's say you have you were asked to divide 3x cubed plus 6x minus 4. And you were asked to divide that by x plus 2. When you write out the polynomial with the x variables in descending order according to their powers, you can see if you have missing terms. So I have an x cubed term and an x term, but no x squared term. So I have a missing x squared term. And what I'm going to do is I'm going to write the x squared term with a coefficient of 0. So I'm going to write it as 0x squared. I'm going to rewrite this. I'm going to go ahead and do my long division, but now I'm going to have 3x cubed plus 0x squared plus 6x minus 4. This is analogous to a situation like if I say, well, I have 107 pairs of shoes. Then what I'm really saying is I have 100 pairs of shoes plus 7. And I don't have anything here in the tens place, but I have a 0 here to hold that place. So we're just doing the same thing here. Now, going ahead and performing the long division just as we discussed. First, I divide x into x cubed. And x goes into x cubed, 3x cubed. Divide right here. This cancels, and this becomes a 2. So that's going to give me 3x squared. So I have, I'm going to put the 3x squared right here over the x squared column. And I'm then going to multiply. So 3x squared times x is going to give me 3x cubed. 3x squared times 2 is going to give me 6x squared. Then subtract. So after you multiply, subtract. And remember, this is the same as adding the opposite. So I'm going to add the negative, the inverse of both of these, the additive inverse of both of these. Okay, 3x cubed minus 3x cubed cancels. Now I have x squared minus 6x squared to yield negative 6x squared. Divide this term. And actually, before I do that, I need to remember to bring down the next digit. So I've got plus 6x. So now I'm going to divide negative 6x squared by x. X's cancel. This gives me negative, one of the x's cancels. So this is going to give me negative 6x. Put that up here. Multiply to get negative 6x times x to give me negative 6x squared. And then I have a negative 6x times 2, which is negative 12x. Subtract. So subtracting, same as adding the opposite. So these both get changed to positives. Subtracting negative 6x squared, actually adding 6x squared to negative 6x squared. That's going to give me 0. 6x plus 12x, 18x. Bring down the next digit, which is a negative 4. Again, dividing. Now I have 18x divided by x, which is simply going to give me, the x's will cancel, I'll get 18. So this is plus 18. Once again, multiplying, that's going to give me 18x. 18 times 2, that's 36. So I'm subtracting. So this is 18x. This is actually 18x right there. 18 times x would give me 18x. 18 times 2 is 36. So 18x minus 18x is 0. And then I have negative 4 minus, so I'm changing the signs here, minus 36 to get negative 40. This gives me 3x squared minus 6x plus 18. The remainder is 40. Again, you could check this by determining that the dividend equals the divisor times the quotient plus the remainder. And you could make sure that this checks out. So the point here is that if you have a missing term, meaning you write the polynomial in descending order according to the exponents, and you look and you see, okay, I've got an x cubed but no x squared, or maybe you have x squared and no x, you're missing one of these powers to x, then you need to put that term in using a coefficient of 0 so that you can perform the long division correctly. You need to have those missing terms represented with a coefficient of 0. Okay, applying what we just learned to examples, beginning with what we discussed at the start of this lesson, which is dividing a polynomial by a monomial. Recall that in order to do that, you're going to divide each term in the polynomial by the monomial. So I'm going to rewrite this as 6p cubed divided by 3p minus 12p squared divided by 3p plus 9p divided by 3p minus 15 divided by 3p. So now that I have it rewritten this way, I just use my normal rules that we've already learned for dividing a monomial by another monomial. So I have 6 divided by 3 is going to give me 2. P squared, or excuse me, p cubed divided by p, that'll give me 1p will cancel out, so I'll be left with p squared. Okay. Next I have negative 12p squared divided by 3, so that's going to give me a negative 4, and I'm going to see that my p squared divided by p, so what I'm going to be doing is subtracting the exponents. I have a 2 here, and this really means 1, so 1p is going to cancel out. Here I have 9p divided by 3p, so 9 divided by 3 is 3, p's cancel out. Here I have negative 15 divided by 3. That's going to give me a negative 5, and it's actually divided by 3p, and that p is just going to stay in the denominator. Okay, so what this ended up giving me is I started out with this polynomial divided by a monomial, split it up so that I'm dividing each term in the polynomial by the monomial, and then I just went ahead and did my usual division. Okay. In this second example, I'm going to first look and see that I have a polynomial divided by a binomial. The easy route is to factor, or to try to factor, and hopefully one of those factors will be equal to n minus 7, and then I can just do some cancellation. If that doesn't work out, I'm going to have to do long division. So really, the only point of the factoring is to come up with a factor of n minus 7 if I can. Therefore, instead of just trying every possible combination, I'm just going to factor 2n squared, or attempt to factor it, in such a way that one of the factors is n minus 7. If that doesn't work, I'm not going to go any farther. I'm not going to look for other combinations because I'm just going to have to do long division anyways. So no reason to complete the factoring. Okay, so what I need to think about are just different factors of 35, and I know that one of them has to be 7. I know that 7 times 5 is 35. And I also know that I have a negative sign here, which means that one of these binomials has a negative sign in it, the other is a positive. And since there's a 2, the leading coefficient is 2, one of these binomials is going to have an n, and the other is going to have a 2n. That only leaves me with one option, and that is that I'm going to have a 5 here. And now I need to check and make sure that this is the proper factoring. So I have n times 2n, that gives me 2n squared. 5n, so that's plus 5n, minus 14n, minus 35. So 5n minus 14n, that does check out to negative 9n. So this is the proper factorization. So I got lucky this time because this is the easy way to go about this division. N minus 7 times 2n plus 5. That's the factoring for the numerator. In the denominator, I have an n minus 7, which means that these cancel out. That leaves me with 2n plus 5 as the quotient. So again, try to factor the numerator. If you're able to factor it, check and see if one of the factors is equal to the denominator, in which case you simply cancel, and what's left behind, what's left over, is the quotient. Okay, in this next example, we've got 4 terms here, which is going to lead to some very complicated factoring, and I'm just going to go ahead and do long division. As always with long division, I'm going to check and make sure there's no missing terms. So I have 3x cubed, I have an x squared term, and I have an x term, and then I have a constant. So there's no missing terms here, so I can just go ahead and do the division. Writing this out so that I can perform long division. Beginning with 3x cubed divided by x. So going over here to just make sure that I'm dividing correctly, I'm going to write it out. So this is 3x cubed divided by x. What's going to happen is the x's will cancel, one x term will cancel, and that's going to give me 3x squared. So up here, I'm going to have 3x squared. Then I'm going to multiply 3x squared times x minus 3, and that's going to give me 3x cubed minus 9x squared. So I'm going to multiply, and I did multiply, so I have 3x cubed minus 9x squared. Then I'm going to subtract going to subtract this. So that's the same as adding the opposite. Change the signs. 3x cubes cancel out. Negative 8x squared plus 9x squared gives me an x squared. Bring down the next digit. I'm going to again divide. So I need to divide. And I'm going to divide x squared right here by x. One x cancels. That leaves me with x. So I just have an x up here. Multiply. X times x minus 3. That's going to give me x squared minus 3x. And then I'm going to subtract. Which is the same as adding the opposite. X squareds cancel out. 5x plus 3x is 8x. Bring down the next digit, which is negative 4. Again, divide. 8x divided by x. X's cancel, you get 8. Multiply. 8 times the divisor, x minus 3. That gives me 8x minus 24. Subtract. We're almost there. Okay, so I ended up with an 8. I need to put that up here. I multiplied that times the divisor to find that I got 8x minus 24. Next step is to subtract. So subtracting, it's adding the opposite. 8x's cancel out. This leaves me with 20. So that is my remainder. I have a remainder of 20. I can always check this. And remember, the way to check it is to say that the dividend is equal to the divisor times the quotient plus the remainder. And so you could check this out by taking your divisor times the quotient, 3x cubed plus x plus 8 plus the remainder. So if you work this out, you get 3x, excuse me, this should be 3x squared up there. 3x squared. Copied that incorrectly. So that is 3x cubed. And then x times x, that's x squared. X times 8 is 8x. Now multiplying negative 3 times each of these terms. And that is negative 3 times 3x squared gives me negative 9x squared. Negative 3 times x is negative 3x. Negative 3 times 8 is negative 24, plus the remainder. I'm going to go ahead and substitute in 20 here because we know the remainder is 20. Now let's simplify. I only have one x cubed term, so that stays 3x cubed. For x squared terms, I have x squared and negative 9x squared. That leaves me with negative 8x squared. For x terms, I have 8x minus 3x, which is going to leave 5x. Negative 24 plus 20 is going to be negative 4. And this equals the dividend. Looking back up, I have 3x cubed minus 8x squared plus 5x minus 4. So this checked out. And my quotient is right up here by long division, and I double checked it. Okay, in order to divide this polynomial by the monomial, we'll have to use long division because this would be very difficult to factor. And the first thing is to take care of the missing terms. We have a y to the fourth term. Missing terms. I'm missing a y cubed term. I've got a y squared, and I'm missing a y term. Therefore, I'm going to rewrite this as dividend divisor. Dividend is 4y to the fourth. Missing term of 0y of y cubed, so I'm going to have a coefficient of 0 there. Minus 2y squared. Another missing term, 0y. I'm going to make sure I have the missing terms included. Then I go about long division, beginning with 4y to the fourth divided by 2y. The 2's cancel. That gives me 2y y to the third. Writing that up here. Next, multiply. 2y to the third times 2y minus 1 is 4y to the fourth minus 2y to the third. Subtract that. Subtraction means adding the opposite. 4y to the fourths cancel out, and I'm left with 2y to the third. Bring down this next term, negative 2y squared. Now divide. I have 2y to the third divided by 2y. 2's cancel. One of the y's cancel. That's y squared. Writing that up here, and then multiplying. Y squared times 2y minus 1 to give 2y squared minus y squared. Actually 2y cubed. Y squared times 2y is 2y cubed. Subtracting. I'm going to subtract this from right here. And that is the same, I'm subtracting all of this, so it's the same as adding the opposite. 2y cubed minus 2y cubed, those drop out. I've got a negative 2y squared plus y squared, leaves me with negative y squared. Okay, negative y squared divided by 2y. One of the y's cancels, so that's negative y over 2. Up here, negative y over 2. Multiply that, negative y over 2 times 2y minus 1. So I have negative y times 2y. That's going to give me negative 2y squared divided by 2. That means that the 2's will cancel. Okay, so for this first term, what I end up with is a negative y squared. I'll rewrite that in a second. I have negative y over 2 times negative 1. So that's going to give me plus y over 2. Since this canceled, I can write it in its simplified form. It's just negative y squared plus y over 2. So that was a bit complex, but all you're doing is multiplying negative y over 2 times the divisor. Then subtracting it as usual. Okay, so I need to go ahead and bring down this next term. So last time I subtracted, I ended up with negative y squared. Bring down the 0y. And now I have to subtract negative y squared plus y over 2. That's the same as adding the opposite. My y squareds cancel. This is just 0y, so all I have is negative y over 2. Bring down the 6. That's plus 6. Now, I've got negative y over 2. I'm going to come right over here and divide that. That's negative y over 2 divided by 2y. Well, recall that if you think of it like this, negative y over 2 divided by 2y. What you're really going to do is multiply by the reciprocal. So that's negative y over 2 times 1 over 2y, which is going to give you, the y's will cancel. It's just going to give you negative 1/4. So that's negative 1/4 up here. Okay, now I need to multiply that times 2y minus 1, and that's actually going to come out to negative y over 2 plus 1/4. And you can see that negative 1/4 times 2y, the 2 is going to cancel. You're going to end up with negative y over 2, and then negative 1/4 times negative 1 is going to give you positive 1/4. Negative, you're subtracting, so you're adding the opposite. That means the y over 2 terms cancel out, which is going to leave you with 6 minus 1/4. 6 minus 1/4 is 5 3/4. So the remainder is 5 3/4. So I'm going to write that up here. So this is a very long, complex problem. We first had some missing terms we had to account for, and then we had division that involved a dividend with 5 terms. Each time you simply divide the term by 2y, write your answer up here, multiply what you get times 2y minus 1, and subtract. This is what's left. Bring down the next term. Again, divide, write down what you get from that division, multiply, subtract. Here's what's left. Bring down the next term. And continue to do that until you're left with either nothing or a remainder. And the quotient is 2y cubed plus y squared minus y over 2 minus 1/4 with the remainder of 5 3/4. So that concludes this lesson of Educator.com.